Let's look at a question where we are given a matrix A and required to find the inverse of A, and then use this inverse to solve this equation given here. So let's look at part 1. Part 1 says given A is equal to 2, 4, 1, 1, find A inverse. So let's solve this. Now remember, to find the inverse of a matrix, first you must find the determinant, which is equal to AD minus BC. In this case, A is 2, B is 4, C is 1, and D is 1. So the determinant is 2 by 1, so that's 2 by 1 minus 4 by 1. So that gives us 2 minus 4, which is equal to minus 2. Then the second step to find the determinant, we must change A such that we switch these two numbers, so that's 1, 2, and then we negate these two, so that's minus 4, minus 1. And the third step to find A inverse is equal to 1 over the determinant by this matrix, which is 1 minus 4 minus 1, 2. So that is equal to 1 over minus 2 to 1 minus 4 minus 1, 2. And that is equal to negative a half, because this times this, then negative 4 on negative 2, negative 1 on negative 2, and 2 on negative 2. So this gives us A inverse as minus a half, 2, 1/2, minus 1. So this here is A inverse. So now that we have A inverse, we need to solve for x and y such that 2, 4, 1, 1, this matrix, times xy equals 10, 3. Now there are a few things to know before we tackle this problem. If we have the inverse of a matrix and we multiply the inverse by the original matrix, so that's A inverse times A, we get something called the identity matrix, which is denoted by I, and it is equal to 1, 0, 0, 1. So the identity matrix by any matrix gives the matrix itself. So let's show how we'll apply this to solve this question. So we have the equation where the matrix 2, 4, 1, 1, which is a 2 by 2 matrix, multiplied by xy, which is a 2 by 1 matrix, gives the result 10, 3. So to solve this, we must first pre-multiply by A inverse on both sides of the equation. So that means we multiply by A inverse here and we multiply by A inverse here. So pre-multiply means that the A inverse comes before this matrix on this side and it comes before this matrix on this side. So this becomes minus a half, 2, 1/2, minus 1 times 2, 4, 1, 1 by xy equals minus a half, 2, a half minus 1, which is the inverse of A, times 10, 3. Now we pre-multiply on both sides because in an equation, to maintain equality, whatever we do on one side, we must also do on the other side. Now we notice here that we have A inverse times A, and we see from this that A inverse times A equals to the identity matrix. So then this multiplied by this gives us 1, 0, 0, 1 multiplied by xy is equal to, and let's multiply this side out. So this is a 2 by 2 matrix and this is a 2 by 1 matrix. So we expect the result here to be a 2 by 1 matrix. So we get minus a half by 10, so that's minus a half by 10 plus 2 by 3. And then we have 1/2 times 10 plus minus 1 times 3. And from this result we know that the identity matrix, which is 1, 0, 0, 1, by any matrix gives the original matrix. So this multiplied by this gives us xy, and we show that here, if we multiply it out, we get 1001 times xy gives the matrix xy. So here we have xy is equal to minus a half times 10 is minus 5, plus 2 times 3 is 6, and minus a half times 10 is 5, plus minus 1 by 3 is minus 3. So that is equal to minus 5 plus 6 is 1, and 5 minus 3 is 2. So here we have xy is equal to 1, 2. So if we equate corresponding terms, we see that x is 1 and y equals 2. And this is how we solve for this equation.